Greetings to anyone who's watching this presentation. My name is Iftikhar, and my teammate Trevor, Haynes, and I are part of Group 6, and we're presenting our project on factors impacting performance in NHL. We did our analysis on two levels. The first analysis that I'll be talking about is on a team level, which is like a macro level, whereas Trevor will be talking about a player level, micro level analysis. For our project, we obtained data from the internet using web scraping. And we're going to focus on data for the season 2017-2018. So jumping right into the team analysis, the first part that we have here shows us that the number of games played by each team are pretty much similar, which is a good start because we want to be sure that there are no outliers as such which could impact our data in any way, or more importantly, our results. Here we see that the games won by each team are or do follow some sort of distribution, and there are no outliers as such, and same goes for the games lost per team. And to sum it up, this plot shows us the games won and lost by the teams in 2017-2018. So this is the data that we'll be using right now to draw some conclusions and to perform some analysis. The foundation of our analysis will be drawn from this plot, which has wins minus losses on the y-axis and the team, the name of the team on the x-axis. Here we see that a negative wins minus loss number means that the team lost more matches than won them, and vice versa. To do a more in-depth analysis, we looked at a few factors, and we started by looking at the average height and the average weight of each team normalized, so that we can get a good comparison here. Here we see that for both average height and average weight, there is no trend as such, and the data is all over the place. So we cannot really make any conclusion about what we're getting out of this or from these two variables. If you look at average age and average seasons, they're both highly correlated, but again, it's hard to draw any conclusion from the impact that they have on teams winning or losing games. But this is where things get sort of start getting interesting. We see that for most teams which have more wins than losses, we see that their average experience normalized is greater than those for teams that have more losses than wins. For now, we're just going to ignore these 2 points, which are of Chicago, and this point right here, which is of Vegas Golden Knights. And these are the 2 outliers which we'll be talking about later on. But this is just to give you an idea of how the salary. I'm sorry if I said that wrong. The average salary of a team impacts the results. This part right here shows us or adds to the last plot. It shows us that as the number of seasons increases, the salaries demanded by the players increase, and then we see this positive slope of seasons with salaries. And here the color of the plot shows the wins minus losses. So as you can see that if you look at the teams above this line, we can see that they're generally lighter in color, which means they have higher wins and losses as compared to those which are below this. On average, we can see that again, the teams that are above this line, which means that higher salary spent, means that more wins and losses as compared to teams that are below this, except for the 2 exceptions which we talked about before, which was Vegas Golden Knights and Chicago right here. Even though the team invested a lot of money in their players, we still do not see the returns that we expected. Whereas this team right here was a new team, and it turned out to be very successful. So what we can conclude from this plot at least is that higher investment leads to higher returns in terms of wins. We also analyzed what the average number of right-handed players has, what the variable has an impact, the impact that this variable has on the numbers of wins and losses, and there wasn't anything that we could draw from this. But what was interesting to note was that there was this very small correlation between teams starting on the right side of the ring as compared to teams starting on the left side and their success. So as you can see, at least these two teams right here, and even these light colored teams, they started on the right side of the ring and they ended up with higher wins than losses, which is an interesting insight, especially if we're looking at a team which is not too successful. Maybe they could learn from this model and start their games on the right side of the ring. So Trevor will now take over the player level analysis, and he will talk about countries and players. Thank you.
So in our next part of our analysis, we're going to compare the various countries in terms of player performance as opposed to looking at teams. So to start off our analysis, we're going to basically disclude any player who didn't play at least 40 games in the season, because this is just going to be introducing outliers in terms of low metrics on a number of different offensive and defensive scores. So just looking at kind of the right half of this distribution. So this is games played for every player in our data set. So first thing is to just see, where do the players in the National Hockey League come from? And the answer is largely Canada and the US, with a few Eastern European and Scandinavian countries, Sweden, Russia, Czech Republic, and Finland also contributing a number of players. So we wanted to basically then ask the question, how do players from each of these countries compare in terms of some of these kind of catch-all metrics that try and aggregate across a number of different offensive or defensive statistics and provide just like a general score of how much a player is worth to a team. And we basically wanted to see, is this disproportionate amount of American Canadian players strictly due to, geographic convenience reasons, or do players from the US and Canada actually outperform these other countries? So just focusing on these 6 countries, as many of the other ones only provide a couple to up to 10 players. So first thing we wanted to isolate is basically just make sure that team or players from these various countries are getting equal ice time, and it appears that they are. So what you're looking at here, so the color is basically the average number of seasons in the league by player in each of these countries. So Canadian players have more experience in the league, but that does not actually result in more ice time. And so ice time is basically just, literally how many minutes or seconds is the player on the ice versus on the bench during a game. And so since these are relatively even, we feel pretty good about making some comparisons between players of different nationalities. So the first metric is just wins above replacement. So that's basically, how many wins is a player worth to a team above what is defined as a replacement level, or kind of like an average player. And you see that Russia and Finland outperform basically every other country on this metric by a pretty large margin. Surprisingly, USA and Canada, although they do similarly, do pretty poorly. And so we, to make this a little bit more granular, we wanted to look at, offensive and defensive contributions specifically. So kind of like a subcategory of wins above replacement is offensive wins above replacement. And so that is, similar metric, but focusing only on offensive contributions. And again, clearly Finland and Russia outperform, especially the North American teams in terms of like worth to their team offensively. And another metric of kind of offensive production is called offensive point share. So this, unlike wins above replacement, does not consider, game outcomes. And it's simply looking, how many goals, assists, how many goals are being scored for the team when they're on the ice, a number of different indicators that a player is contributing offensively. And now the interesting difference between this offensive point share and wins above replacement metric is that Finland is now ranked last, where they were ranked second here. Russia does well in both, but the difference between the top teams and the other teams is a little bit smaller. So, our hypothesis was that basically players from Finland, while they maybe are scoring less in aggregate, their goals scored are worth more in terms of wins, and the opposite being true for the Czech Republic. And so when we look at critical goals scored, and that's defined as basically any goal that ties the lead or causes your team to take the lead in a game, this is averaged again over all the players from each of these countries. You do see that there is a difference between Finland and the Czech Republic. And so importantly, here it may look like a very marginal difference, but because wins are weighted so heavily in the wins above replacement metric, and goals are weighted evenly regardless of when they occur, in the offensive point share, a small difference here may result in a pretty substantial difference in wins above replacement. So, and then just to, verify that assumption, does critical points and offensive wins above replacement, do they have a positive correlation? And indeed they do, pretty clear. So now to look at defensive metrics, the defensive version of wins above replacement produced some pretty interesting results. You see players from Russia, while they're very offensively talented, maybe defensive liabilities on average to their teams. Surprisingly, Canada scored pretty poorly on this metric as well. Because when we then look at the defensive point share metric, so that's again the defensive and analogous version of offensive point share, Canada does the best. And so, this really didn't make a lot of sense to us. These are two metrics that are supposed to be, capturing basically a player's defensive value to their team, and they're showing two different stories basically. So when we plot these two metrics against each other, it shows that there's basically no correlation between the two. And so that's that's interesting because teams definitely use these metrics to evaluate players, but how can two defensive metrics not be correlated at all? So we then wanted to see do teams actually use both of these in terms of valuing players, or is one used and one is not? And sure enough, when we look at salary, and this analysis is limited to defensemen, as they are evaluated purely on their defensive abilities. Salary and this defensive wins above replacement metric have basically no relationship, while defensive point share and salary has a pretty strong positive correlation. So that tells us that this defensive point share is probably capturing more useful information than the defensive wins above replacement. So in conclusion, basically that North American players, they don't outperform their peers in terms of these kind of catch-all statistics. And that kind of should indicate to hockey clubs that are trying to invest resources into developing international players. They should look to countries like Russia and Finland to devote scouting resources and looking to develop young players in that country. And then finally is that this defensive wins above replacement statistic is potentially not really capturing useful information, and teams, analysts, or journalists should avoid using this to make any conclusions about a player's defensive ability. Then kind of as a final cherry on top, this is an unrelated visualization, but we were just curious about within the United States, where are American players coming from? And so it turns out that a large proportion of American players are coming from Minnesota. They got a lot of lakes, so a lot of frozen pond hockey is one hypothesis as to why so many players come from there, and same with Michigan and New York. And then Massachusetts, highly population dense state, and again, strong hockey culture there as well. So these four states really dominate the American player market. And yeah, so that's basically our analysis, and thanks for watching.